Good morning, folks. I don't normally do this, so I thought this would be a nice change. Hope all of you are doing well. I posted an assignment for you, but before I explain a little bit about that, you may be able to do the assignment without even listening, but to this. But I thought that maybe I could share with you a little something that I picked up since I've been here in Philadelphia since what, '98. So lesser celandine. You see a picture of that. And we can take a look at this picture up close. It's really pretty colors, nice yellow. It's what we call an ephemeral. Comes out early before the leaves on the trees leaf out and shade the ground. You'll see this a lot in Philadelphia, especially along the streams and rivers, and even in the suburbs as well. It's got a heart-shaped leaf. Um, it looks pretty, but you could tell right there that that is an area that has been just covered in this stuff, and it is considered an invasive. It pretty much covers the entire area in a few years because of the proliferation of bulbs. So if you ever see this, not only get rid of it, but you actually have to dig it up because it has these little bulblets underneath. So a little public service announcement there. So what I do want to explain to you a little bit is the I want to explain to you a little bit is the problem that I gave you today. So the first thing I want you to do is I want you to do using bond energies. I want you to calculate the energy needed to break all of the bonds and the energy needed to create that chloroform, and I think it was the hydrogen chloride gas. So use bond energies. You're going to get a total, okay? You're going to get your energy in to break the bonds, and then your products. So we're going to say combine, and we're going to see which one your total. Is it a negative number, which would be exothermic, or is it a positive number for endothermic? So that total number is really important because what I'm asking you to do is Cl, this is chloroform, and there's not a heat of formation for chloroform, meaning we don't have in the appendix how much energy is needed to make this. So we're going to use our bond energy total to figure it out. And how we're going to do that is going to use the other heats of formation for the other two reactants and the one product, because those are in the back of the book. And we're going to figure out if you can determine this number for the heat of formation. And finally, tomorrow I'd like everybody to be present for a Google, no, we won't do a Google Meet, we'll do a Zoom. And tomorrow's lesson is going to be looking at bond energy and the energies needed for breaking and forming bonds with fuels. So think about all the fuels that we use in our lives, whether it's natural gas in our homes, propane in our barbecues, gasoline in our cars, heating oil, all of those different energies, something called ethanol, all of those energies needed, especially while we're here in a time where it's not too warm out, so you need the heat of your house. In order to travel, you need, well, not so much traveling right now in terms of airplanes, but you need the fuel that goes into airplanes, which we'll talk about a little bit tomorrow as well. So I hope this finds you well. I thought maybe a video would be helpful, and especially in trying to find out the heat of formation for that chloroform.